In this section, we will examine operators and calculations in MQL5. In most programming languages, these operators are divided into 4 categories: arithmetic operators, comparison operators, logical operators, and assignment operators. With arithmetic operators, you perform a mathematical operation such as addition, multiplication, or division. With comparison operators, you compare two numbers to see if one is greater, smaller, or equal to the other, and so on. With logical operators, you want to evaluate two logical conditions together, which will get 2 AND. With assignment operators, so far you've become familiar with the basic assignment that uses the equal sign. It allows us to assign a value to a variable. Let's go into the IDE environment and get to know these operators better together. First, we'll review the arithmetic operators together. These operators include addition, subtraction, multiplication, division, and actually modulo or remainder, which gives us the remainder of dividing two numbers by each other. I'm going to create a variable called a and assign the value 10 to it. I'll define a variable called a and another variable called b and assign the value 3 to it. Now with these two variables we have a and b. Let's check these operators together. For example, let's see what output we get if we add these two variables, these two numbers together. I'm going to print it out. As an explanation, I'll say this is the sum print, meaning we're adding a and b together, which equals. Now I'll use the actual operator. So a plus b. And I end my line with a semicolon. And now let's compile this together to see what output it gives us. Okay, some changes have been made here. Yes, yes, yes. Let's compile it. Let's go to Meta Editor. We open MetaTrader and drag our indicator onto the chart. And as you can see, a plus b equals 13 because it added 10 and 3 together. So what was this? It was the addition operator, meaning it added them together. What was the output? It was 13 because they were added together. The next operator is the subtraction operator. When we subtract one from the other, this operator is called subtraction. Sorry, it's called subtraction. And basically it subtracts one variable from the other. Our next operator is the multiplication operator, which we use when we want to multiply two things together. So multiplying 10 by 3 gives us an output of 30. Our next operator is the division operator. As you can see, it gives us a decimal value, 3.3333, and so on. And finally, the operator that you might not be familiar with yet is the modulus operator, which calculates the remainder of the division of two numbers for us. That is, it tells us what remainder we get when the first number is divided by the second number. 10 divided by 3, as you know, is 3. 3 times 3 is 9, and it leaves the remainder of 1. So the output will be the number 1 as a remainder. All right, let's compile this and go to the chart. As you can see, the sum of two numbers, subtraction, multiplication, division, and the remainder of 10 divided by 3, which is 1, have all been calculated and printed for us. The next operators we want to examine together are the comparison operators. This means that we compare two numbers with each other using these operators. The output of comparison operators is different from the output of arithmetic operators. Why? Because the output of mathematical operators is usually a number. For example, when you add 10 and 3 together, you get 13 as an output, which is a number. But with comparison operators, you get a Boolean variable as the output. That is either true or false. For what purpose? In the sense that you can ask whether 10 is greater than 3 or not. The output of this comparison is a yes or no, which is a Boolean. So the output of comparison operators for us is a Boolean variable whose value can be either true or false. Let's go and examine these variables together on the chart. To be more precise, these were arithmetic operators, and now we get to comparison operators, which we want to examine together one by one. The first operator we want to look at is the equal to operator, which is made up of two equal signs next to each other. Here, it gives us an output indicating whether A is equal to B or not. I'll comment these out so we don't have extra prints on the chart. And let's go over this first one together on the chart. We open our meta editor, compile it, and then go to our MetaTrader. We remove our indicator. I'll add the indicator to the chart again. And as you can see, our output is false, meaning it has given us false. This expression, where A double equals B, is what we've written here. As you can see, this is our own output, and this is essentially the expression we're looking for here, which gives us a true or false output as the result of the equal to comparison operator. As you can clearly see, it is indeed made up of two distinct and equal signs. The very next important operator we will be discussing is the not equal to operator. How does it work? You place an exclamation mark to the left of your equal sign, and its output tells us whether A is not equal to B or not. When our A is 10 and our B is 3, well, obviously these two are not equal, so the output here should be true. Let's check it together. We'll compile it, go to the chart, and see why it didn't give us any output. Let's remove our indicator from the chart. We'll compile it once more and drop it onto the chart here. There is no output. Let's see why it didn't produce any output. The reason is that we didn't save our file before trying to compile it. Now let's see. Yes, you can see that the not equal to operator between A and B has returned true for us. All right. The next operators are straightforward ones. The less than operator. Let's also look at the greater than operator together, which tells us whether number A is greater than number B or not. Well, its output will definitely be true. Here, as you can see, 0 represents a false output and 1 represents a true output. The next operator is the less than operator. The next operator is the greater than or equal to operator, the greater than or equal to operator, and the next one is the less than or equal to operator. All of these perform a comparison between these two numbers and give us an output. Save, compile, and as you can see, the outputs are shown to us as well. For example, the number 10 is greater than or equal to the number 3, so the output is true, but the number 10 is not less than or equal to the number 3. What was the last one again? We haven't gotten there yet. We haven't reached this part yet. The AI itself added that. All right, the next operator we want to talk about is logical operators. What do logical operators do for us? They compare two statements logically, not just two numbers. Notice here that on both sides of our comparison, we have two statements, and those statements can be numbers or they can be statements themselves, which we'll examine together now. For instance, let's say we want to clearly see how two specific conditions that we've carefully set for an indicator or an expert advisor can be effectively compared with each other. So I create a condition as a Boolean variable and name it condition 1, setting its initial value to true by default. And for condition 2, I set its value to false. So one is indeed true and the other is definitively false, establishing a clear distinction between them. Now, I want to use logical operators to compare these two statements, where one is actually true and the other is false. The first logical operator we want to compare together is the AND operator. I say, for example, print my condition 1 and my condition 2 with, and between them, like double ampersand. Then we say, compare my condition 1 and my condition 2, are both of them true or not. The AND operator is the AND operator, meaning both condition 1 and condition 2 must be true. If both of these statements are not true, it returns the value false for us. Let's save it again together, compile it, and check the chart to see what the output is. Condition 1 and condition 2 give a false output. Why does it give a false output? The reason is that our second condition is false, and for the AND operator to give us a true output, both of our conditions, which are our statements, need to be true. They have to be true at the same time. So if I set this to true, save it, and compile it. Enter meta editor compile. And as you can see, since I changed it and both of our conditions here are true, the output of our comparison operator, logical operator, which is the AND operator, also becomes true here. So if even one of these is just false, the value that the AND operator outputs for us will be false. The next operator we want to compare together is the OR operator, or the YA operator, which is represented by two vertical bars. This operator checks whether just one of them, and as you know, OR means if either one of these two conditions is true, only one of these two conditions needs to be met, condition 1 or condition 2. So it's enough for just one of these to be true, and the output we get from this will definitely be a true output. Let's check it together. As you can see, our output is true. Why? Why is the output of our operator true? Because one of our variables is true. Now, if I set both variables to false, the output of our OR operator will also be false. So I will set this back to its previous true value, and then let's proceed to move on to the next logical operator, which is specifically the NOT operator. The NOT operator, it's represented by an exclamation mark before any of our conditions. It works in such a way that if the condition we have is true, it turns it into false and outputs that, and if it's false, it turns it into true and outputs that. Keep in mind, it actually shows us the opposite of our condition. So right now, our first condition is true. Therefore, with the NOT operator at the beginning of this condition, we'll get a false output. So if we compile it like this and come here, as you can see, the NOT operator has given us a false output, even though our variable itself has a value of true. So these are three of our logical variables that we reviewed together. Next, in the operators section, we get to the simplest part of operators, which are the assignment operators. We became familiar with the assignment operator, which is simply an equal sign. We said that the value on the right side of the equal sign is assigned to the left side, and it's used for assigning values. But we can also use a slightly more advanced approach by combining these assignment operators with mathematical operators, which we will cover together. Suppose I want to assign the value 200 to a variable, let's say variable d. Well, as you can see, assigning the value 200 is exactly my assignment operator at work, right? Let me write above as well that we are going to review assignment operators. But there is another type of assignment. Suppose I want to add 100 to variable d and assign the result back to d. What does that mean? It means I want to say that whatever value variable d has, which right now is 200, add another 100 to it, and assign it back to variable d. For this, we can use the add and assign operator. In fact, this operator, d plus equals 100, this operator, as you can see, works exactly the same as this kind of operator and this statement. So we can write this on the left side and comment out the right side. Similarly, for subtraction, we can use the corresponding operator, which is the subtract and assign operator. As you can clearly see, the subtract and equals operators are precisely placed together in this particular instance, and the resulting value obtained is indeed d minus 100. This demonstrates the direct application of these fundamental arithmetic operations. The next operator we'll look at is the multiply and assign operator, which multiplies and then assigns the result. As you can see, it multiplies and then assigns. The next operator is divide and then assign, which divides d by 100 and stores the result back in d. After learning about operators in programming languages, it's also necessary to understand the precedence of these operators, which brings us to the topic of operator precedence. So that we can examine these together. If I define a variable e and then say add the value of 10 to 20 and subsequently multiply the entire result by 3, what precise output will it give me? Does it first add 10 and 20, which makes 30, and then multiply by 3? So 30 times 3 is 90, and it outputs 90. Or does it first multiply 20 by 3, which makes 60, and then add 10, which makes 70? As you can see here, 20 is multiplied by 3 first, and then 10 is added. The reason this happens is that the multiplication operator here has higher precedence than the addition operator. So the operator that takes precedence here is the multiplication operator. Now, together, we want to examine the precedence of these operators relative to each other and see which ones are more important than the others. The first precedence that always exists among operators is the parenthesis operator. Although it is not recognized as a mathematical operator, it is actually considered a logical operator. And if you use any operator inside parentheses, that particular operator will always have absolute precedence over all other operators outside the parentheses. So, for example, if I were to add the numbers 10 and 20 together inside those parentheses, I would actually get the final result of 90 as the ultimate output. Because after that, it will be multiplied by 3. 10 plus 20 is 30, and multiplied by 3, it will output 90. The next operators are the unary operational operators, which we have already worked with and are familiar with. For example, if I say this is equal, if I want to add a true and a false value together, for instance, if I say true plus false, this operator, which is actually known as not, is one of the unary operators. In mathematical operations and operator precedence, we won't deal with these operators much, because they're mainly used with true and false values. But the next section is about division and multiplication operators. For example, you should know that the multiplication operator always takes precedence over the division operator. That means we will handle the multiplication operator first. Pay attention. 10 times 20 gives us 200, and after dividing by 5, it gives us 40. But what would happen if this precedence didn't exist? In mathematical operators, the precedence between multiplication and division isn't that important. Why? Because both are performed at the same time. You can first divide 20 by 5, you get 4, and then if you multiply it by 10, you still end up with 40. So we can generally say that multiplication and division operators are on the same level of precedence. So far, we've examined the basic principle of operator precedence, but to complete it, let's add that after multiplication and division, addition and subtraction operators come next, followed by comparison operators, and then logical operators. So in this particular sequence, the higher up you are positioned, the sooner that specific operator will be executed for you, effectively determining its priority and timing. So if you ever want to make sure that an operator is definitely executed first, you can always use parentheses to be certain. And if you don't want to stick to this sequence and order, or if it's too complicated for you, in any case, you can always use parentheses. You can be sure that the operators inside the parentheses will be executed before the other operators. Good luck.